Welcome to this hopefully exciting video on finding least common multiple and greatest common factor using prime factorization. This is super exciting. This is not the traditional method of finding LCM and GCF, but this is a way that will work every time, and you can end up finding the GCF and the LCM at the same time while practicing prime factorization, while learning cool things about numbers. It's really pretty awesome. I hope I can convince you by the end of the video that this method is a great way to find LCM and GCF. All right, so let's start with the numbers. We will start with the numbers 45 and 30. And we're going to find both the LCM and the GCF of those numbers using prime factorization. So I listed the steps here so that you can kind of look at them and follow along as we're going through. Just refer back to them when you're doing this on your own. So we're going to start by finding the prime factorization of both numbers. So I'll start here with 45. I will break that up into, let's see, 3 times 15. Got one prime factor. Then 3 times 5. Those are both prime factors. So I've got 3 times 3 times 5 as the prime factorization of 45. Now let's find the prime factorization of 30. I can do 3 times 10. 3 is prime, and I can do, let's see, 2 times 5. Those are prime. So I've got 2 times 3 times 5. Okay, so I wrote both prime factorizations in expanded form just so that I could see each number separately. Now, step 2 is to create a Venn diagram. So I'm going to draw these circles, leaving plenty of room for myself in the center for any common prime factors. All right, now let's go to step 3. So I'm going to look at both prime factorizations and place common prime factors in the center. Venn diagram kind of compares and contrasts things. So if this is the number 45 here, and this is the number 30. Everything in the center of the Venn diagram is what they both share, and everything on the outside are things that they don't share. So let's go through and see if we can identify what prime factors they do share. So looking at this list of 45, 3 times 3 times 5, and 30, 2 times 3 times 5, I see that they both share a 3 times 5. So I'm going to take those common prime factors and write them in the center of the Venn diagram. So I'm going to write that as a multiplication problem like that, 3 times 5. Great. Okay. Next is to place leftover prime factors on the outsides. I'm pretty sure leftover isn't spelled like this when you're referring to prime factorization, but just bear with me for this. Let's go back to our prime factorizations. I see that 45 has a 3 left over, so I'll put that here. And 30 has a 2 left over in its prime factorization, so I'll put that here. So you can actually see the prime factorizations of both numbers. If we look, 45's circle has 3 times 3 times 5, and 30's circle has 3 times 5 times 2. Great. So now let's look. The product in the center is the GCF, which means right here, this product, 3 times 5, which is equal to 15, is the GCF, or greatest common factor of 45 and 30. And then looking at the last step, the product of all the numbers in our Venn diagram, so this whole string right here, and I'll just write that off to the side, 3 times 3 times 5 times 2. Whatever that is, 3 times 3 is 9, 9 times 5 is 45, 45 times 2 is 90, That is our LCM. If we've done it correctly, this will always work. In one fell swoop, we can find the GCF and the LCM of two numbers using prime factorization in this handy dandy Venn diagram. Let's try one more example together. All right. So let's try this time. Let's use the numbers 42 and 28. All right. So I'm going to start off by finding the prime factorization of those two numbers. Okay. Now remember, if you've seen the prime factorization video, you know your prime factorization doesn't have to start with the same two numbers mine does. It just has to end in the same result of a string of prime factors. So for 42, you could start with numbers like 21 times 2. You could start with numbers like 6 times 7. However you want to start, I'll start with 6 times 7. I'll circle 7. It's prime. The factors of 6 are 2 times 3. I'll circle those. So the prime factorization of 42 is 2 times 3 times 7. And let's do the prime factorization of 28. I know that 7 times 4 is 28. 7's prime. And 2 times 2 equals 4. Circle 2, circle 2. So the prime factorization of 28 is 2 times 2 times 7. All right. So we found the prime factorization of both numbers. Now let's draw our Venn diagram. I'll draw that over here. Whoops. All right. Here we go. I'll label this circle 42. I'll label this circle 28. It's nice to label your Venn diagram circles so you don't get them too confused. So now let's go through and identify what prime factors they have in common. So 2 times 3 times 7, 2 times 2 times 7, I see that they share prime factors of 2 and 7. Cool. All right, so let's write that 2 times 7 in the center here, 2 times 7. And just a quick note, in these past two examples, there have been 2 factors in the center. There could just be 1. There could be 3. There could be 4. There could be 5. There could be as many as there need to be. There's no specific number of factors that needs to be in the center here. So we'll go back and see what's not common in these. So this one, 42, has a 3 left over, so we'll write it here. And 28 has a 2 left over, so we'll put that here. All right. So our GCF is what's in the center. That's right here is the GCF. 2 times 7, which is equal to 14, is the GCF. Greatest common factor of 42 and 28 is 14. And then, last but not least, this whole string of numbers that we have up in our Venn diagram, also known as 3 times 2 times 7 times 2, that's our LCM. So let's try to work this out. We've got 3 times 2 is 6. 6 times 7 is 42, and 42 times 2 is 84, and that is the LCM. And look at this. We've got our GCF and LCM right together. All right. Now, here's one last problem that you can try on your own. Pause the video once I give you the numbers, try it, and then come back and check your work. So try to find the LCM and GCF of the numbers 25 and 20. Pause the video to try to solve it on your own. All right, so we are finding the LCM and GCF of 25 and 20 using the prime factorization method. So prime factorization of 25 is 5 times 5. That's a pretty simple one. And the prime factorization of 20 is 4 times 5. Nope. Whoopsies. Did you see what I did? Consider that not circled. 2 times 2. Then let's go back and write the actual prime factors. 2 times 2 times 5. Bonus points if you caught my mistake there. I circled 4. I shouldn't have. It's not a prime number. I just got really excited about this prime factorization that only had 2 numbers. I thought 20 might be that way too. It doesn't. All right. So now let's write our Venn diagram. Label this one 25. Label this one 20. And we'll go through, identify what they have in common. So 25 has a 5 and a 5. 20 has a 2, and a 5. Looks like they only have one 5 in common. So that's the only number I'm going to write in the center. Then I'll go through and write 25's leftover numbers on the 25 side, which is a 5. And I'll write 20's leftover numbers, a 2 times 2, here. And that means that the GCF of 25 and 20 is just 5. There's no products to find, it's just one number. So 5 is the GCF. And look at the string of numbers we have over here. We have, whoops, 5 times 5 times 2 times 2. Well, 5 times 5 is 25, times 2 is 50, times 2 is 100. So 100 is the LCM. Pat yourself on the back if you got that right. Nice job. 5 is the greatest common factor of 25 and 20, and 100 is the least common multiple. Thanks for watching.